In this lesson, we will cover Unit 2, Section 2.7, Applying the Trigonometric Ratios. In this lesson, you will learn how to use a primary trigonometric ratio to solve a problem modeled by a right triangle. From our previous lessons, you know that the primary trig ratios consist of the sine, cosine, and tan ratios. It's important that you remember which ratio to use for what side of the triangle. Now we're going to look at how to solve a right triangle. Solving a triangle means to determine the measures of all angles and the length of all sides in the triangle. In previous questions, we would only be asked to find one angle or one side. Now we're going to use several ratios or the Pythagorean theorem to solve for all sides and all angles. When we calculate the measures of all the angles and all the lengths in a right triangle, we are solving the triangle. We can use any of the primary trigonometric ratios to do this. As you can see on the right hand side, we have our three ratios, and we're going to have to determine from here on out which ratio to use in which circumstance. It is important to label your triangle first, opposite and adjacent hypotenuse, compared to the theta or the angle that is given. That is always a clear first step to do. So there are some guidelines to help you solve a triangle and to help you realize where to start. If given a question where there is no diagram, it is important to first sketch that diagram, label all the sides, and place all known information correctly on the triangle. Drawing a correct diagram is very, very important. If your diagram is incorrect, then you could quite possibly solve the triangle incorrectly. After you sketch, label, and correctly place all the known information on the triangle, you're going to use the information to select the correct trigonometric ratio and apply the Pythagorean theorem, or it could be used. Apply the knowledge that the sum of the angles in a triangle equals 180 degrees if you're trying to find a third angle. And if you need to find the third side of a right triangle, you can use a trigonometric ratio, but the Pythagorean theorem could be applied a little more easier. So in our example here, we have this triangle, KMN, and we need to solve for all sides and all angles. As you can see here, for angle N, if we label that triangle according to angle N, opposite would be 7.0 centimeters, and adjacent would be 11.0 centimeters. We're going to use the tangent ratio to help find the angle for angle N. So you have tan theta equals 7.0 divided by 11.0. You want to rewrite that as a decimal, which gives us 0.63 repeating. In order to find the degree measure, we're going to use the inverse function of tan. So we have tan inverse 0.6364, which equals theta. And approximately angle N will equal 32.5 degrees. So now if we want to go back and fill in angle N to be 32.5 degrees, we will quickly realize that we have two known angle measures, and the third one could be found by going 180 degrees, subtract 90 degrees, subtract 32.5 degrees. And this will leave us with angle K to be 57.5 degrees. Now that we have all the angles found, we can continue on to find the side lengths. So we have two side lengths given already. Now we have to determine a strategy we could use to find K to N. One that you may quickly realize is the Pythagorean theorem, where we just have to find the hypotenuse, or you could use one of your trigonometric ratios. You could use angle n, where you could have to find the hypotenuse using the sine or the cosine ratio, or you could use angle k. But the easiest thing here to do would be use the Pythagorean theorem. So k to n is the hypotenuse. We're going to have that squared and equal to the two legs squared, 7.0 squared plus 11.0 squared. As we go through the steps of the Pythagorean theorem, we will determine that the length of k to n is approximately 13.0 centimeters. In your final step, it might be nice now to take your measures of your angles and your sides that you found and label your triangle to ensure that you have found everything you need to do in order to solve that triangle completely. In summary, we have our three ratios: tan A equals opposite and adjacent, sine A, opposite and hypotenuse, and cos A, adjacent and hypotenuse. In a right triangle, to determine the measure of acute angle, you can do this when you are given the length of an adjacent leg or the length of the hypotenuse. First, you can do this by determining cos A using the given lengths, or use cos inverse on a scientific calculator to determine the measure of angle A. So that's your two steps that you have to follow there. In a right triangle PQR, to determine the length of the hypotenuse, QP, when you are given the measure of angle P, and the length of the leg QR, there are four steps. Identify the ratio to use and write the equation. Substitute the known values. Solve the equation for the unknown length. And if you need to take it a step further to determine the length of leg PR, you can use another trigonometric ratio or the Pythagorean theorem.